Hey guys, welcome to question MM380 of the Maths Methods Fortify study guide. So in this question, John is taking a maths exam. The multiple choice section on the exam has 22 questions, which each have 5 potential answers. John is a very poor maths student and guesses every answer. That is, he has a 20% chance to answer any given question correctly. Now, given that he got at least 8 correct answers, the probability that he got exactly 11 correct answers is closest to. Alright, awesome. So what we're actually looking for is the probability that he got exactly 11 answers, given that he got at least 8 correct answers. Okay, so even though the given is first, it says given that he got at least 8 correct answers, that's still our given. So it's like, what's the probability that he got exactly 11, given that he got at least 8? So, according to our general given formula, we have probability of A given B equals probability of A intersect B over probability of B. Which means that the probability of x equals 11 given x is greater than or equal to 8, or at least 8, equals the probability that x equals 11 intersect x is at least 8 over the probability that x is at least 8. Awesome. So the intersect between x equals 11 and x is greater than 8 is just x equals 11. And the easiest way to kind of visualize this is on a number line. So let's say we've got an 8 here and an 11 here. Probability that x equals 11 is here, and the probability that x is greater than or equal to 8 is from here onwards. The intersect between those two things, or their common ground, is only at 11, right? So that means that the intersect is just x equals 11. So what we have is the probability that x equals 11 over the probability that x is greater than or equal to 8. Sweet. So now we have to actually figure out what these probabilities are. So the fact is that we need to recognize that this kind of probability is binomial, all right? Because he can either get it right or he can get it wrong. And there's multiple trials or multiple attempts at this sort of thing. So there's 22 attempts, and they all have the same probability of getting it correct. So in order to find each of these probabilities, we go into our binomial CDF, and we say that, well, it's going to ask us for 4 things: n, p, lower, and upper. Okay, so n is the number of trials, or the number of attempts. We have 22 attempts, 22 questions, so n is 22. We have a 20% chance to get any given question correct, so our p is 0.2. Our lower, in this case, so we're just dealing with this x equals 11 to begin with. Our lower is 11, and our upper is 11. Now you can use binomial PDF and just simply put in x equals 11. I just like to keep doing CDF just to keep it consistent. So lower is 11, upper is 11, and what that gives us is the probability that x is 11 equals 0.0012. Sweet. Now again, we're going to use our binomial CDF to find our probability that x is greater than or equal to 8. So this time our n is still 22, so we're still dealing with 22 questions. The probability that we get any of them correct is 0.2 still. The lower bound this time is 8. Okay, so we're looking for greater than or equal to 8. So our lower bound is 8, and our upper bound is 22, right? Because we're looking for the probability that that John scores between 8 and 22. So lower bound is 8, upper bound is 22, which means that the probability that x is greater than or equal to 8 is equal to 0.0561. So these are our probabilities, which means that this is equal to 0.0012 over 0.0561. Awesome. Now, what this spits out is 0.0221, which is our answer of E. So E is our answer, guys, for MM380. If you have any questions about this binomial distribution stuff, please let me know in the comments below. But otherwise, thank you for watching, and I will see you in the next video.